Okay, so we're going to take this time now to relate those card hands to Pascal's triangle. And just to be forthright, of course, this is not quite associated to poker, but you get the drift. So we're kind of talking about cards here, and we're talking about probability of cards. Now, when we get a hand of 5 cards, okay, some of those are going to be black, some of those are going to be red. So we can kind of write that as a binomial, black plus red. It's going to be some combination of those two, and we're getting 5 cards. Okay, so jump back up to Pascal's triangle here. We know that you have the 0 power, the first power, second power, third power, fourth power. This line right here represents the binomial expansion of your 5th power. And since we're talking about 5 cards, that's the one we're going to be working with. So I'm going to pull that down here. 1, 5, 10, 10, 5, 1. And I'm going to expand that binomial, which as we know is black and red. So I'm going to take b to the 5th, b to the 4th, b to the 3rd, b squared, b to the 1st, b to the 0, which is 1. I'm going to take r to the 0, which is 1, r to the 1st, r to the 2nd, r to the 3rd, r to the 4th, r to the 5th. Okay, and then we put this together, right? So you're basically multiplying that whole row. 1b to the 5th. Right here would be 5b to the 4th, r to the 1st. 10b cubed r squared. 10b squared r cubed. Sorry, that was that one. 5br to the 4th. And 1r to the 5th. Okay, so that's how you would expand that binomial if we were just multiplying it out. Now, how we're going to get this back to cards here is that also represents probability. Okay, what it's saying is you have right here 1 chance to get 5 blacks. You have 5 chances to get 4 blacks, 1 red. 10 chances to get 3 blacks, 2 reds. 10 chances to get 2 blacks, 3 reds. 5 chances to get 1 black, 4 reds, and 1 chance to get all 5 reds. So if we add that up there, there's 1 chance, 5 chance, 10, 10, 5, and 1. That gives me 32 possibilities. Okay, well now you can see how we're getting close to probability here. So if I have 32 possibilities, and let's say I wanted to know the probability of getting all blacks. Well, all blacks would be this first term. To get all 5 blacks, I got 1 chance out of that 32. Well, 1 divided by 32 gives me about 0.03, which as a percentage, is about 3%. So that means out of every 100 hands that we deal, 3 of those are going to be all 5 black. Okay, so remember, percent is always out of 100, right? So out of 100 hands, 3 of those hands are going to give me all 5 black. So that's just getting black, let alone getting all spades or all clubs for a flush. So pretty low probability there, right? Which is why it's a pretty good hand to get. let's just say, for sake of argument, let's say that instead of playing 5-card stud, which is 5 cards, you play what you got. There's a poker game where you can play 5 cards and draw 1. So if it's 5 cards and draw 1, then I would only need to start with 4 blacks, right? So for sake of argument here, and again, we're talking blacks, not suit, so it's a little different than poker, but this term right here is going to represent 4 black cards, 1 red card. And that has 5 chances out of the 32 to get that. Well, 5 over 32 is approximately 0.16, which is about 16%, which means out of 100 hands, you're going to get 4 black, 1 red about 16 times. Okay, well, let's see how this played out in our demo. And you guys are just going to have to trust me. I shuffled them 7 times. I cut the deck in half. Those are true poker hands there, okay? So let's see how it played out. Well, here's the cards that I'm working with, right? See if I can move this up a little bit. Not quite. Okay, so here's the cards that I'm working with. Gonna have to go back and forth. We said that to get all black, all 5 black, there's a 3% chance, which out of 10, that's 1/3 out of 10. So really, very, very small chance, right? So did we get any hands that were all black? And as I'm scanning through, no, we did not, okay? And that kind of matches up. Now, keep in mind, if I were to do 100 hands, you're going to get closer and closer to this, what you would call a theoretic probability, okay? What I did laying out the 10 hands would be an experimental probability because I'm actually doing it. The mathematical calculations behind it are really theoretic, but the more experiments you do, so if I had done this 100 times, you're probably going to get pretty close to seeing 3 hands of straight black. But that still makes sense because really low percentage. In our second one here, we said, okay, what about getting 4 black, 1 red? And that gave me a 16% chance. So that's a little bit better than 1 out of 10. So let's see, 4 blacks, 1 red. I got 4 reds, 1 black. There's 4 blacks, 1 red. 4 blacks, 1 red. 4 blacks, 1 red. That's my dog. So we actually got it 3 times here, which would be higher than expected. Okay, you'd expect to get it, you know, about 1, maybe 2 times. So 3 is pretty high. So I must be feeling lucky. I should get to the casino today. But that's kind of what we're looking at. So this would be your theoretic probability. Okay, using Pascal's triangle. And then down here, this would be an experimental probability. We actually did that. And it makes sense, or it's pretty common that in a small sample like that with just 10 hands, you're not going to get real exact in terms of what you came up with mathematically. But the more times I did this, if I had done 100 hands, you're going to see that get really, really close to what you did with the math. Okay, so what I would like you to do is there's another poker game, and again, I know we're using poker a little bit leniently here, but you can play with 7 cards. So 7 card stud. So you're getting 7 cards. What would your probability be of getting 5 reds? So 7 cards. I want you to find me the probability of getting 5 reds, which would also mean you're getting 2 blacks. Okay, see what you can do. So you're obviously going to use Pascal's triangle there. But see if you can come up with something for that. And